Okay, so here we're starting off with number 23. Now this is a surface area question, and remember what I told you, they're always going to make you work for it. So be aware of that before we even get started. Now we have to find the lateral area of the cone, which is a curved portion of the cone, and then we have to add it to the surface area of the sphere. So we have to treat these two shapes separately. Let's write out what we have to do. So we have to find the surface area of our sphere, and then to that we have to add the lateral area of our cone. And in my little visual here, I'm going to go ahead and highlight what do I mean by lateral area. I mean just that curved portion, not the area of my base. So I'm going to substitute in the formulas here. For surface area of a sphere not given to you on the EOC, you're going to take your volume formula, which is given on the EOC, and basically get rid of all the 3's in the formula. So the surface area for a sphere is the formula 4 pi r squared. And in this case, we have a radius. It is 12. So I'm just going to plug in what I already know. 4 times pi times 12 squared. So 12 squared is 144. So I'm doing 4 times pi times 144. So 4 times 144. That's 576 pi. Okay, just making sure I typed that in correctly. Yeah, 144. Okay, now let's move on to the lateral area of the cone. Now, lateral area for a cone, you have to memorize this. You have to memorize the lateral area formula for a cone and the lateral area formula for a cylinder, all those curved shapes. So for a cone, the formula is pi r L. And in my diagram here, L represents the slanted length. That would be L right there. Let's take a look if we have everything in our diagram. Pi, the radius is 12 for my cone, just like the sphere. And then the slant length L. Okay, now that we do not have. So L would be this length right here, and we don't have that. So we're going to have to solve for it, because what we have is the height. 16 is the height of the cone. It's h, but it's not L. But luckily, we can do some Pythagorean theorem work here, and we could solve for L. So with this right triangle on the inside, I have L, which is the hypotenuse of this right triangle. That's going to be my C value in a squared plus b squared equals c squared. So I'm going to write down 12 squared plus 16 squared equals L squared. 12 squared is 144 plus 16 squared, which is 256, equals L squared. 144 plus 256 is 400. That's L squared. Square root both sides, so 20 is L. That's the length of the slant. That's the slant length, 20. All right, so now I have the L. Plug that into my formula, it's 20. So I'm going to multiply 12 times 20, 240 pi. So now I need to add 576 pi plus 240 pi. I'm going to add the two coefficients together first, since they're both in terms of pi. So I get 816 pi. And now they're asking us to use 3.14. So I'm going to multiply by 3.14. So 2,562.24 is what I get in my calculator. Now the question asked me to round to the nearest tenth of a square inch. So that means I'm going to put down 2,562.2. All right, next question. Okay, now in this question, we need to find the measure of angle ZYD. I'm going to zoom in a bunch so I can put in what I'm looking for. I'm looking for this little angle there, ZYD, right at the top. Okay, now things that I am looking at my diagram and noticing. I notice that in the prompt, they told me that the length of XY, that one tick mark, is the same as the entire bottom side. So that means that all of angle Y and all of angle Z are congruent. Those two angles are entirely congruent. Now, if I ignore all the other line segments in the diagram, what I have is I have an isosceles triangle because I have those two legs congruent. So if I'm thinking about that diagram there, and I'm thinking that these two sides are congruent, I have an angle that's 48 degrees, I know that the bottom angle y and z are congruent. So I'm going to solve for those angles because maybe I can get at least the whole angle y, and then later I can figure out just that piece. So since every angle in a triangle should add up to 180, I'm going to subtract 48 to see what's left over for my two congruent angles. So 180 minus 48 leaves me with 132 degrees. Then I divide it by 2 so I can get each angle, and that's going to be 66 degrees for each angle. So in this diagram, angle y is 66, and then all of angle z is going to be 66. Now, since I have a little right angle symbol at D, that means to the right of angle D is also a right angle. So I already see a way that I can get the missing angle at the top. I see that this little right triangle here can allow me to figure out that missing angle up top. I'm going to redraw that right triangle. Okay, so now with my right triangle, I have that being 90. I have angle Z being 66. That's what I just solved for. And I'm looking for this angle at the top. I'm going to subtract what I have from 180. So 180 minus 90 minus 66. Let's see what I have left over. Minus 90 minus 66. 24 degrees is left over for that angle at the top. That's going to be my final answer. Choice A is 24 degrees. Now, you could have figured this out a lot of different ways, but that's the approach that I used. Let's move on to the next question. Okay, question number 25. We're asked about a 30, 60, 90, the special right triangles. Now, they tell us that the shorter leg is 6.5 centimeters long, and the goal is to find the length of the hypotenuse to the nearest centimeter. I'm going to draw that special 30, 60, 90 triangle. So 30 degrees I'll put here, 60 at the top, and then here's my 90 degrees. All right, so the shorter leg is 6.5. Remember that your shortest leg is the one that's across from your smallest angle, which is 30 degrees. So my shortest leg is 6.5 centimeters. This is the leg that's across from 30, and it's what we call X when we do our special right triangles. The side next to, adjacent to the 30, is X radical 3, and then your hypotenuse is 2 times that shorter leg, so 2 times X. Now, since I have X, I don't have to solve for X. It's really simple in this one. They gave me the side length. That's my starting side length. I need to just plug it into 2x. So 2 times 6.5 is going to give me my answer. So 2 times 6.5 is 13. So I'm going to put in that my length for the hypotenuse is 13. Let's move on to the next question. Okay, next question. All right, here's a circle question. And circles are pretty fresh for us, so let's see what we can do. Now, the question asks you to find the measure of arc AC. So this arc right here. Now, what we have is we have the vertical angle of 80 degrees, which is the same as the vertical angle across from it. And we have the intercepted arc on the right, which is 100. Now, if you remember what I tell you to do, I tell you to take your highlighter, whatever it is, you're going to highlight and shade the two vertical angles to pay attention to your intercepted arcs. When we have vertical angles like this, they're just free floating in the center here. They're not on the center, they're not on the circle, they're just free floating in the middle. What you do is you use a formula for vertical angles of a circle, which is vertical angle equals arc 1 plus arc 2 divided by 2. When the angles are inside, you add. So our vertical angle we have, it's 80. Arc 1 and arc 2, well, one of the arcs is missing, so we'll call it x, and then the other arc is 100. So we're going to write down x plus 100 divided by 2. Now we need to solve algebraically. So multiply both sides by 2 so we can get rid of the denominator. We have 160 equals x plus 100. We're going to subtract 100 from both sides, so we're left with 60 for x. And that's the measure of our arc. Okay, let's move on to the next question. All right, now 27 asks you to visualize which one of these would be the net for your cube. For F, if I fold it over this top portion, it's not going to create a three-dimensional figure. It'll create what looks like a right angle, or like a couch, but it won't create a full cube. So it's not going to be choice F. Now choice G, same thing. These two right here are going to fold over, but I'm going to be missing a side on the bottom here. So it's not going to be choice G. Now for H, I'm going to have this portion and this portion wrap around on both sides. And then this tail will complete the cube as it wraps the whole way around. So right now I think it's going to be H. And now for I, even if I were to fold this, I can fold this over several times, but there's nothing that's going to close out the other two sides of my cube. So can't be choice I. It's going to be choice H. So you have to practice with this visualization stuff because there's no tried and true way to answer this question other than to visualize. Let's look at number 28. All right, now 28 is probably the worst shape for most students, and it's always wrong. A right triangular prism. It's very difficult because most people assume that this is a pyramid, or they think that your base is a rectangle. In this case, our bases, right, the two sides that are parallel in this case, is going to be the triangle in the front and the triangle in the back. So this is a triangular prism. Now you have to find surface area. So you're going to break this shape up and you're going to find the area of each side and you're going to add them. Now we have two triangles, the front and the back. To get the area of one triangle, it's going to be 1/2 base times height. And since I have two, I'm just going to make sure I multiply by 2 because they're congruent. So in this case, I have 2 times 1/2 base and height. The base of my triangle is 7. And then the height of my triangle, it's going to be 25, just like in the back. Okay, I'm sorry, 24, just like in the back. So 24. It's not going to be the 25, that's your hypotenuse. So that's going to give me the area of the two triangles. Let me go ahead and figure that out. 24 times 7 times 0.5 times 2, basically cancel each other out, and we get 168 for the area of both triangles. Now we need to take care of the rectangles. So for the rectangle on the right, okay, this side here. So for that rectangle, we have side lengths of 15 and 24. So we're going to multiply that together. 15 times 24. So my area is going to be 360. Now let's take a look at the next one. So my bottom is 7 and 15. So 7 by 15. 7 times 15 is 105. So I have 105 for the area of the bottom. And then the last side that I have here that I need to solve for is the slanted one. Now that one's a little tricky. Okay, so that one that's slanted, the dimensions are, for the bottom, it's going to be your 15. But then for the height, that's the 25. That's the slanted portion's height. So it's 15 by 25. So in my calculator, 15 times 25 equals 375. Add all of those together. So 375 plus 105 plus the 360 plus the 168 for both triangles, and I get 1008 as my final answer. 1008 units squared. Okay, let's continue on to the next video.